Hello everyone. Okay, so we have this question on light waves which reads, an optical fiber is made from glass with a refractive index of 1.5. The fiber is surrounded by a cladding with a refractive index of 1.4. Calculate the critical angle for the total internal reflection at the core cladding interface. So the first thing we have to take note of first here is that the critical angle is found by this formula, sine theta. This is the critical angle. This is equals to index 2 over index 1. So the critical angle is the angle of incidence in the denser medium, which is the core, above which the total internal reflection occurs at the boundary with less dense medium, which is the cladding. So in this case, we can say N1, let this represent the refractive index of the core. That is the higher refractive index in this case, of which the higher refractive index is 1.5. So this will be 1.5. Then this will be the refractive index of the cladding, with the one with a lower refractive index, which is 1.4. So now that we have this, we can go ahead and calculate theta. So sine theta is equals to 1.4 divided by 1.5. Hence theta is the sine inverse of 1.4 divided by 1.5. So this gives us a critical angle of approximately 68.9 degrees. 68.9 degrees. But B of the question says, if the light inside the fiber hits the core cladding interface at an angle of 65 degrees, will total internal reflection occur? Show your working. All right. So the simplest explanation for this one is that total internal reflection occurs only when the angle of incidence is greater than the critical angle. In this case, the angle of incidence we've been given as 65. So the idea is this: if I is greater than the critical angle, then total internal reflection will occur. But in this case, we can see that our I is 65 degrees. Our critical angle is 68.9, what we've just calculated. So in this case, the critical angle is greater than the angle of incidence. So because of this, total internal reflection will not occur. As simple as that. So part C says, explain the importance of refractive index difference between the core and cladding in optical fibers. So the main difference is that the refractive index ensures that light traveling through the core is reflected back into the core when it reaches the core cladding boundary at sufficiently steep angles. So this guides the light along the fiber through total internal reflection, like we've just shown that the reflection will not occur. So without a sufficient refractive index, what will happen is that light would not refract into the cladding. Also, remember, these are optic fibers, so we expect the signal to be lost and the fiber would not function as efficient as it's supposed to be in terms of guiding the wave. So there we have it. We have answered this particular question.